Welcome to AJ Tutoring's YouTube channel. My name's Steven, and today we're going to be talking about AP Physics 1 torque. Before we get started, be sure to check out our content below, and let's get to it. Today I want to talk about just kind of a general torque problem that I've seen a ton tutoring, which is a mass hanging from a sign or something like that from some ropes. And so we see this kind of problem all the time where we have a rod on a hinge point connected to probably only one cable, but I'm going to draw three just because I want to run through kind of all the general cases that you can see here. And so say we have a rod of length L, and then this is at L over 3, and this is at 2L over 3. So we have kind of point A, B, and C, and then we have tension A, tension B, or tension C. So if you see your problem and you have one of these cables, like hopefully I'll be able to show you where your problem is, and say I have a mass hanging from here. Again, if you have a mass hanging from here or here, I'm going to kind of talk about that. We're going to run through a lot of these. So this situation, because it's a mass, hopefully, because it's a sign, hopefully it shouldn't be like swinging around or anything like that. So this is a statics problem. And by statics, what we mean is that the sum of the torques, which is typically equal to I alpha, alpha, which is the angular acceleration, is going to be equal to 0 because everything's being held still here, everything's fixed. And so the sum of the torques are all going to be equal to 0. And this is really important. This is kind of the crux thing where we can say what all these torques are going to work out to because it's equal to 0. So remember that torque is typically, if you look on your equation sheet, you'll see this as well, but torque itself is equal to F perpendicular times whatever torque arm. I believe it's R on your equation sheet. So this is F perpendicular. All this is saying is that the force has to be perpendicular to the torque arm. So this torque arm here, this force has to be perpendicular to that. If it's not perpendicular, that there's no torque. This is just pulling along the rod. That's certainly something's happening, but it's not torque. So typically you'll see this as F R sine theta, where sine theta is simply if there's an angle between this, the tension in the cable, and the rod, that angle, you simply plug that into here and you'll get some factor, and that's the amount of the force that's actually going perpendicular to this. But in this case, we'll just say these are all 90, and so the sine theta is going to be 1, and so we don't have to worry about it. So we just have F and R for each one of our torques, and so we're going to have 1, 2, 3, 4 different torques for each cable in the mass. And so we just start with this, the sum of the torques, so we say 0, that's this 0, is equal to the sum of the torques. So I write down the first one, which is going to be TA times the torque arm, which is L over 3, plus TB times the torque arm, which is 2L over 3, plus TC times that torque arm, which is just L. And then in the opposite direction, because all of these torques are acting upwards, so that was going to look counterclockwise to you, and then all of these are going to go clockwise, so the M, so because this is going the opposite direction, this is going to be mg, and then the torque arm 2L over 3. So if this mass, for example, like I said, was hanging from this location, instead of 2L over 3, you just get L over 3. If it was here, instead of 2L over 3, you would just get L. So you could put this wherever you want to. You could put it at 4L over 5, like wherever you want to. And that torque arm is just going to show up here. So I'm going to move this over to the other side, just because it's minus, so mg2L over 3. And then depending on which one of these cables you have, bring that term down. Whichever ones you have, bring them down. Whichever ones you don't have, leave them be. So let's just say I'm going to stick with just TC. So say I don't have these two cables and I just have this one. So I'm going to have TC times L. And then if I solve for TC, you can see I just cancel the L, and TC is equal to 2/3 mg. You can also see that if this rod were massive, some of the times they say that, the rod's massive, you can add a mass to the center of mass of the rod, which in this case would be at L over 2 if it's kind of a uniform mass. So this would be at L over 2. And I would simply add on a term for that that looks like this one. So I'd add on another minus mg L over 2, and that would end up over here. So I'd end up with kind of a plus mg L over 2. And then that would work out in the solving as well. L's would cancel, and I'd end up with a plus mg over 2. So hopefully you could kind of work out where your problem sits in all of this. And even if you have an angle, you can kind of work out how to analyze these problems. Thanks for watching. Be sure to like and subscribe. And if you have any other questions about torque or physics or any other tutoring for that matter, check out our website here or more content below. Thanks.